your domain is your possible x values. It's easier to figure out where the domain is restricted sometimes than it is to try to worry about where the domain is at. What I mean by that is, if I'm looking at a function like this, f of x is 2x plus 1. Is there any value of x that this problem won't work for? I mean, any real value of x. Let me restate that like that. It's going to work for any number. There's no hole in it. There's no, remember vertical asymptotes when you're dividing by zeros, that kind of stuff. When you're worried about domain restriction, it winds up being where you're going to get a non-real answer or a 0 in your denominator. The idea is if you take f of x, let's do another sheet here. F of x is the square root of x plus 4. And I want to figure out what the domain is going to be of that. You guys probably have graphed. You got your notebook, right? I'm just going to get to you. You found it over there? Yeah. You guys probably graphed square roots before. Square root graphs are very easy to use. When we did square root stuff, we just picked numbers that are easy to work with. You pick your perfect squares. 0, 1, 4, 9, 16, things like that. And then we just make that little curve and then we go through. We weren't able to pick numbers. We stopped at 0 for our perfect squares because anything smaller than 0 would give us a non-real result. We were only graphing in the real world. Remember that, right? I think this year we will talk about graphing in the complex world, but that's not, I don't think that's for quite some time. It's not that difficult, it's just kind of weird. So in this case here, what I'm looking for is what value of x will this be restricted to so that it won't work anymore? What does the x have to be greater than to make it work? It's got to be, you're right, it's greater than -5, but if you say it's just greater than -5, what happens if I say it's -4.5? Will that work? So how, restate, you're right, so you want to say it's greater than or equal to -4, all right? See how it's very, you're right there, but once you start looking for that counterexample, it's very, very, so this one here, my domain, will be all the values of x that are greater than or equal to -4. I don't remember if this book writes it in terms of such that. I think the other way to write it out is values of x such that x is greater than or equal to. Let me get their book open. When they talk about domains, they write it like that. I always forget. I think I might be ahead of myself where you guys have to worry about writing it like that, to be honest with you. No, they don't write like that, so don't worry about it. Okay. So your domain has to be greater than or equal to -4. So going into what we have today, after Debbie gets the number of autograph, she's awesome. Completely. I didn't put the volleyball on it though, so I didn't know. You want to hit?
I think he's posting him on Twitter, which is
I know, it's so
like they might as well be like.
I think just
The other one?
There's like 2.
The other one was.
there was another one?
Yeah.
I didn't see it. I didn't see it.
Yeah, it's her and Joseph walking.
You never know, you might find it tomorrow. I'll print it off in a minute. I want to get this through first, okay? So, what we're going to do today that's totally different and totally new, it's called a difference quotient. A difference quotient is one of the basic things that you guys will learn when you get into calculus. We will work with this difference quotient more so second semester at the tail end. What works out nicely is that it fits in with what we're doing today in terms of what's called function notation. Our f of x and substituting in and things like that. This difference quotient is the basic piece of calculus. What this will allow you to do eventually is that it will be able to find the slope of a tangent line to any curve. Or find the slope of really anything. It's kind of like the basics of as you get into it. Now, this is just a really fancy way of writing it out. This formula part here is how a difference quotient is used. I've got 3 or 4 examples of how it goes through, and if you guys are halfway decent with substituting in with function notation, this is really very easy. Okay? Can you divide by 0? No. If you divide by 0, you get an undefined function. So that's why they just put that. That's why they say that. Okay. Did anybody hear her question? Why h can't equal 0? The reason why they throw this little piece in your h can't equal 0 is because you cannot divide by 0. That's the only thing. All right. It's just it's a generic way of writing it out. Okay. So let me show you an example of how this works. Oh, but before I do that though, for some reason I've been forgetting to give you guys these, and I don't know why. Pre-calc, we always give you guys this formula sheet from Augustana College. They send them free to us and say, hey, you guys should think about going to Augustana. Because they give you free things. Quad Cities. Is that where? It's one of them.
They give us periodic tables too.
Oh, they do?
Yeah.
Oh.
They're laminated like this.
Aren't they? They are fancy.
Ooh, they're different.
Really? That's cool. I probably need more. But what's nice with these things, it's got so many of the generic formulas and things that you guys will use throughout the school year. Your areas, your volumes, it's got some basic trig functions. It's got some great, what do you call it, trig stuff on the back, on the top there.
The one that doesn't stay.
Do you know what? You guys need 2 more? One.
Yeah, my brother's friend.
Hey. Yes! It's so easy to use. I'm not lying to you. It just looks really weird. Okay. You have to trust me. I haven't lied to you yet. It'll say, it's blatantly obvious. It'll say, find the difference quotient given such as this. It's that literal. When we do derivative, you'll have this already in the back of your mind. You'll know what that is. It's really, really easy. Okay. Did everybody get one? Or do we still need another one? You might send that one back because I don't know how to count.
You never make mistakes, right?
Correct. The other beneficial thing towards you guys is that Fontana happened to mention to me today. He goes, oh, by the way, pre-calc, we usually let them have a note card on quizzes. I don't remember. Was it? I never taught it, so. So this little formula sheet doesn't go on quizzes and stuff. But unless we say it, I don't remember. But you get to have a note card. So it's like Christmas. I don't remember. I honestly don't know. Except for something I taught it.
It's on my note card.
Well, it's just the idea of, do you need to know? I mean, it's just for your usage and such that things. Anything you want, you know, how do you find domain, that kind of junk.
We get to take more than one.
No. Well, you only get to use one.
Hey,
Yeah.
what did you give them?
It has to be handwritten, not mechanically reproduced.
Darn it. One size one.
No, that can't be a rule.
My rule.
I've had my best chemistry final of my life. My algebra, I'm typing it all on there.
So, let me show you guys what this looks like. I'll get them for you. I just gave up on counting. Let me show you guys what this difference quotient looks like when we get into actual problem. So, if you're asking, what will this look like? it'll say use the difference quotient and simplify. They're going to give you a function. In this case, they gave us a function that is f of x equals 2x plus 5. And it wants us to find this simplified.
So they don't give you an
H, you're going to see what happens with the h's. This value of h in here, no? I need it for other people. What? No, I just get them from when I walk back there. What happens with these values of h, the whole goal of this, when you distribute, simplify, and work through your function notation, the h's in the denominator should cancel out, bless you, should simplify out, if you will, out of an h value in the numerator. As you go through this, it looks really weird. But all this is saying, function notation, function notation. Take the value of x, and what am I going to substitute in for it right off the bat? X plus h. So I rewrite 2 quantity x plus h plus 5. I took care of the first part. Just like you did yesterday when you had your function notation. If you had your function notation from yesterday, we had f of x is 3x minus 1. What is f of 3? Well, you took the 3 and you substitute in. You got 3 times 3 minus 1. It's the same thing. It's the same thing. Second part. Let me move this part over a little bit. Second part says subtract the original f of x. Well, the original f of x would be 2x plus 5. Notice what I did with my brackets. Since I'm subtracting the whole thing, I'm going to have to distribute that negative to both terms. That's where you're going to make your mistake. Make sure you remember to distribute the negative to both terms. Okay? To that, it's all being divided by h. So, distribute, simplify. I get 2x plus 2h plus 5 minus 2x, and then what you're going to screw up, minus 5. And it's still all over h. Oh, nice. Where I'm going with this. What drops out? The 2x drops, and the 5's drop, and I'm left with 2h over h, so my answer is 2. So the difference quotient of my original function, f of x, is 2x plus 5. The difference quotient equals 2. Because what was the slope of the line 2x plus 5? 2. Convenient, isn't it? Does this change if I have a quadratic? Nope. I just have to be careful when I'm squaring stuff to remember that junk squared is junk times junk, and I don't kill puppies. Oh, I have to worry about it. I overwrote that. My bad. So we're going to do the exact same thing. We're going to use the difference quotient for f of x equals x squared minus 4x plus 7. What I'm going to do is, excuse me, I have to substitute in that x plus h in for x first. So we had the quantity x plus h squared minus 4 x plus h plus 7. That first step satisfied just substituting in that part. F of x is 3x minus 1. What is f of 3? 3 times 3 minus 1. F of x is x squared minus 4x plus 7. What is f of x plus h? taking the x plus h and I'm substituting in for x. I'm doing the same thing. It's not changing. Now I have to subtract the original function. But remember, when you go to subtract the original function, make sure you throw that in parentheses.
Just explain that first part.
The substitution part,
Yeah.
remember,
Then you're gonna get like
it's okay. You still distribute out. What does that tell me to do with the shoe? Correct. So I get shoe squared minus 4. Okay. If I have I'm going to go back to it. What do I do? Create x.
and that it just like messes with the other ones. It just like
X plus 1 and remember, when you're doing that, it's x plus 1 quantity squared. This is back and forth. So you have to FOIL it through. Okay? It's first outside, inside left.
Not like inside.
Yeah.
Oh man.
That's stuff like that all the time.
That was TJ.
Oh yeah, buddy.
It works.
You work
Why do you need another one?
It ran out of ink. Hey,
Why do
wait.
you throw it away?
You
How
can
does
drop
it?
it. Yeah, like it ran out of
it. Now I will.
Wait,
No, no,
what does it
try
do
right
when
on
you
the
draw
board.
with it?
No, I want
It ran out of ink.
No. Thank you. Get that like
Anyway, so for all intents and purposes, this is the same idea, but instead of having two variables, we have a variable and a number. I would still do the same thing where I would FOIL out x squared plus 2x plus 1 minus 4, and I get x squared plus 2x minus 3 would be my solution for that. Okay. Now, if I'm doing it this way, this is just basically two parts put together in one problem. If you want, you can do this part first, write it down. After you write this part down, then you just subtract the original function. And what I'm doing here is that this function is not just a singular term. Since it's got multiple parts to it, it's a polynomial. I'm going to put that whole piece in parentheses so I remember to distribute the negative. If anything that you'll screw up, you'll forget the distributive of the negative. Right, Colton?
Right.
And I know this all has to go back over h. So I FOIL it out. When I FOIL this out, I'm going to get x squared plus 2xh plus h squared.
Foiled it out.
X plus h, you get x squared, xh, xh, h squared. Easy. It's algebra that you've been doing for a long time. I should not have to go back and reteach how to FOIL, guys. I really should. Minus the 4x. Oops. Over your negatives, tack on the 7, and then subtract out the rest.
No, it didn't.
Thank you. I just saw it as you under the no. I'm like, oh, it's a plus. Then I combine like terms. Now, what I'm going to do here, since I got to combine like terms anyway, is we all agree that this is still all over h. Do I need to write it over h? Like I just combine like terms and then simplify. It's not a big deal. As you go through this, you'll notice you've got what? We have the x squared and the x squared. So long. 4x, 4x, 7, 7, and I'm left with
H squared.
H
plus
squared.
2xh. Minus 4h. 4h.
what's the GCF up top then?
H.
H. I can factor out an H. And then the-
What did you change? H on top of the H.
yeah, I was just showing how then these two drop through.
Oh, okay.
Okay. So what happens here is that your solution for this whole thing winds up at, the technical way to write it would be 2x minus 4 plus h, put the h at the back end. Any combination is fine. Okay? All we're doing is distribution, combine like terms. Okay. Distribution, combine like terms.
Alright.
And there's your generic rule for that. Let's do another one. We'll try another one. It might even be on that Augustana sheet. Those crazy Augies, they do stuff like that. Augies. You're right, yeah, it is. Oh, well, yeah, of course, you would know what it is. It's just funny that I remember that.
Yeah.
Same idea. We're going to use the difference quotient for 2x squared plus x minus 2. And we're going to use the x's and h's. I do know if you want to break it into two parts, take care of this part first, write it all down, then take care of this part later, write it all down. It's completely fine. It just takes a little bit more space. That's all. It's not a big deal. Sir?
So the short way of doing it would just be just adding h to that first bracket, and then minus it, putting that.
Mm-hmm.
Is that it?
That's really all it is. But you got to be careful when you have the square terms here. You got to make sure you throw it parentheses so you can FOIL it out. Because it's not just x, it's x plus h, quantity squared. Because right there, the x is what's squared. So when you put x plus h in for x, it becomes a term. Just like we did. Watch. You get 2 x plus h quantities.
Yeah.
What I mean by taking care of that, just that first chunk of x plus h, you can just simplify that first if you'd like. If it's a little less daunting, because it lets you, because it doesn't look as crazy if you want. You get the same result. We have 2x squared, 2xh, h squared,
Wait, why did you
because it's 2 times x squared. If you want to go that route, then distribute through, it's fine. And now, at this point, I've taken care of that x plus h portion. Now I can write in the difference part. Okay? If you want to go this route, or if you want to go back and just do it all at the same time, it's not a big deal. Remember, I have to subtract all of these. I have to subtract 2x squared, subtract the x, and then add 2. You okay with that?
What did it
Remember, all I'm doing here, yeah, that's all I'm doing, just changing the signs.
Right.
Since I'm subtracting the original function, in essence, all I'm doing is changing the signs of all of them by distributing out the -1. Okay? If you want to write the step, write it. If you don't want to write the step, don't write it.
Yeah, the 2x squared cancel out.
Yes.
Okay.
So this becomes minus 2x squared minus x and plus 2. Okay. When I distribute the negatives.
How you said, like, is it negative? Yeah. The x.
You wrote it, oh, this should have been x plus h.
No,
Yeah, because we substituted.
so then where's this one being just
I did.
x?
I did. I wrote it right here. It's the x plus h. There just wasn't a constant in front of it. This time it's just an x value.
Yeah, we're,
Yeah, what is that?
that's when I was just like,
Did I forget to write it down?
Yeah.
Oh, there.
oh,
This is why I don't do it in chunks. I just do it all at once. And I don't mess. I didn't even realize I did that, guys. I apologize. I just got to here, and it should have been the x plus h in here, and then a minus 2. So then there should be another plus x plus h and a minus 2 here. I'm sorry. That's why it all looked weird. I apologize. This is why I don't do it in chunks. I just do it all at once. Everybody see what I screwed up?
yeah.
I'm sorry.
It's
Thank you. So what happened was, I forgot to, after I distributed out and foiled all this stuff, I kept going. I just forgot to bring it back into here and bring it back down here. So now I have all of it that I'm supposed to have. Now I can simplify. 2x squareds go away. The x's go away. The 2's go away. And we're left with 2h squared plus 4xh plus h. And what is that all over? H. Bless you. Factor out the h, very good. Don't forget to put a 1 there. It's the same process each and every time. It really is. There really isn't a scary screwball way of doing this problem whatsoever. Aside if you chunk it and you forget to bring out that extra piece of it. That's about it.
So then just leave it as a 2x plus 4.
Yep. Technically you should put the x first. That's all. And then h would come out at the end. There's a reason for that. You'll see when we get towards when we do derivatives later on. Do this. I think I have one more here. Nope. Let me get another one here real fast. When I factored out the h, I took out the h from this thing. Let's try this one. Now I'll look at this real quick. Same. And what was the same rule here? Same idea. Same basic idea.
Why is like the x squared?
Oh, I see what you did. I see. Okay. You forgot to write. That's all it was. And then you would have just changed all the signs to square. You just forgot to do that. Everything was perfect, you just forgot to piece that out. The Devin looks.
How many are using
You You'd be surprised how easy these are as you get going on them. Let's try this one again. Just straightforward, substituting through. We're going to replace x's to start with x plus h. This one's a little bit messier because there's two values of x. So it's a little bit longer. All right. So we have 3x plus h minus x plus h quantity squared.
Okay, yeah,
That's the first part. Then I have to subtract 3x minus x squared. Of those three parts that we just wrote down, which one of those are you going to screw up when you
the last
simplify?
part, because they're gonna do 3x minus x squared, but really it's negative 3x plus.
I was more
I
worried.
didn't do square.
I was more worried that you were going to forget when you FOIL out the middle one, you'll forget to distribute that negative. Okay? So just be careful. We get 3x plus a 3h minus, I'm going to leave this in parentheses to remind us here, x squared, a 2xh, and an h squared. And now, like Maddie was just saying, go ahead and change your signs. Minus 3x plus x squared. The way that this was written itself out is that you have to be cautious because your squared term was a minus a squared term. So you have to be careful to not forget to distribute the negative to the three parts of the trinomial. Yeah, and that's why I'm trying to remind you guys, when you're squaring stuff, make sure you throw parentheses around it. So that way it reminds you, oh, gotta go back and not screw this up. And hopefully go from there. So change your signs. We have a 3x, 3h, negative x squared, negative 2xh, negative h squared, negative 3x, and a positive x squared. It looks like our 3x's and our x squareds will both drop out. And what's nice is that we have all the rest of our terms, they all have an h in common, which is good because that means we can factor it out and because we're still dividing by h. So I have, let's see, 3h, or 2xh, and then h squared. This becomes all over h still. Yep. Oops, put the h first. Yeah. Yeah. This is the last little bit in here. Yes, sir. Yeah. I think on the homework with tonight, I want to say there's 3 of these in the set, but the rest of it is basically domain stuff. It's pretty, the bulk part of tonight's assignment of day 2, pretty easy. Pretty easy. Pretty easy. This is the only goofball, this is the new stuff. Now remember, when you're reading, there are times that it'll say something, not just x plus h, it might say f of 5 plus h, f of 5. So the only thing that changes is you, instead of rewriting with x's, you're rewriting with exactly. It's the same process. It is that literal as you go through it. It's direct substitution on crack. Which one do you got?